it's my privilege to introduce the lead Vault engineer, Jeff Mitchell, to talk about Vault and how Vault can solve problems in your organization at almost every level. So please give it up for Jeff Mitchell.
How's everyone doing? Good, I hope. Let's get to it. So we talk a lot about HashiCorp tools being usable at any application, any infrastructure, right? That's something that we say quite a lot. So here's the question. When we're talking about secure at that middle layer, any application, any infrastructure, really? One thing we hear a lot is Vault is an encrypted key value store. I hear that from people that have been using Vault for like 9 months, a year. I mean, people that that's the only thing they want it for. And then sometimes they'll add on, oh, it also does encryption as a service, right? It does a lot more than that. It does a whole lot of things. And it can be used to address a large number of needs at every level of your infrastructure. And in this talk, I'm going to prove it, and I'm not going to talk about the KV store. So what is Vault? A tool for managing secrets. So I am, and this is true, a trained hypnotist. So let me read this to you in a nice and mellow voice. Vault secures, stores, and tightly controls access to tokens, password certificates, API keys, and other secrets of modern computing. Vault handles leasing, key revocation, key rolling, and auditing. Through a unified API, users can and sleep. Okay. Marketing is going to do what they're going to do. But let's look behind the curtain and talk about what HashiCorp really thinks of Vault. We think of it as a security Swiss Army knife. It's a bunch of useful tools bound together with a unified access mechanism. And really, like a Swiss Army knife, a bunch of useful tools, unified access mechanism. It's the handle. Those are called backends in Vault. They're a bunch of tools. And it's one of the reasons that getting used to using Vault is often so overwhelming. You have all these different tools, backends, and you often have tools within tools, backends that can do lots of different things, such as transit. So Swiss Army knives, they're useful functionality for everyday survival in the woods. Vault is useful applied security with unified auth and auth-z and auditing for everyday survival in the data center. It's a single service API to secure, manage design requirements, policy, and audit. And this is actually something that's really key to why Vault is useful for so many people, is that single service API. A lot of times you hear microservices, that's what we talk about. Nomad is built around microservices. And people make the mistake of thinking that security should necessarily be treated as a microservice. There are many things that you can gain by having a single service that you can manage, like what TLS options you want when you're talking about exchanging database credentials or exchanging passwords or ciphertext, what the auditing looks like, right? Having a centralized store for security is not necessarily a bad thing because it means you can apply policy everywhere. And just kind of as an anecdote here, there's a very, very large company that made the case to us a while back, and we did actually add this in, for having random byte generation in Vault, where you can go into transit right now and you can call an endpoint, and it'll give you a bunch of random bytes. And the reason is that they decided that they were actually much more comfortable having this unified way of all of their developers getting random bytes and taking the hit on latency rather than going to a local machine, than trusting that their developers would get random bytes properly everywhere from every language on every platform, right? So there's something to be said for having this kind of unified approach when you're talking about things that are security sensitive. And so Vault really tries to be this jack of all trades and master of some. I say master of some because some of the things that Vault does are pretty world class. Like the PKI backend is something that we hear from a lot of people is one of the most kind of easy to use, sort of flexible CAs that are out there. So there are many things that Vault does very, very well. So let's get to it. I promised I would show about how Vault can integrate at every level of your applications and infrastructure. Let's talk about a pretty normal setup, users, browsers, machines, and apps, and databases. But first, before we can actually talk about how Vault is usable there, we need to actually be able to talk to Vault, and that's something called secure introduction. So secure introduction is a process of getting that first token to a client, securely introducing that client to Vault. Seth, who you just met, who introduced me, Seth, when I was planning this talk, said, you should talk about secure introduction. People always ask me about secure introduction. I hate giving talks about secure introduction. I really hate it. It's really important. You can't use Vault without it. But I'm going to give you an example of why I hate giving talks about secure introduction. Here's something that I'll see in my typical week. Quote, we have Chef and trust it absolutely. It's the only way we trust to get Vault tokens to apps. Versus, we have Chef and don't trust it at all. Why would we possibly send around Vault tokens or Vault credentials through Chef? I really, really hate giving talks about secure introduction. Here are some rules for secure introduction. Number one is, I can't tell you what to do. I cannot sit up here and tell you what to do to get that first token to a client, talk to Vault. And to get all my 90s references out of the way up front, rule number two is I can't tell you what to do. And it depends hugely on a number of things. Infrastructure, hardware security modules, deployment models, your orchestration system, communication channels, what third parties you trust, your org security policies, right? All of these things play a big role in what kind of secure introduction might work for you, what that workflow will look like. And most importantly, it's who or what you trust. Do you trust your Chef server if you have Chef? What about Puppet? Do you trust AWS? Do you trust, do you trust SSH? Like, what do you trust in your organization? Rather than give any sort of like concrete, like you do this, I'm going to give some suggestions and guidelines. If you're not a Vault user and you're not planning to become a Vault user, this might be very in the weeds, but we'll sort of get through this because we do have to talk about getting that token to you. So some suggestions for bare metal. If you have SSH, if you have a deployment infrastructure, if you have SSH that you trust, you can use it to connect to a machine and provide a token or credits. If you have TLS, if you have an existing TLS setup, you can use the cert out the backend to get tokens. Configuration management tools, Chef, Puppet, Ansible, Salt, you can use that. And if you have a RAM disk or TPM, you don't really want to store a token and persist it to bare disk unless that's encrypted. So you can have the process periodically refresh it if you store it like in a RAM disk or if you store it in TPM storage or something. So there are many things you can do with bare metal, but this might be the most highly dependent on like deployment methodology that you have is the bare metal scenario. Some of the auth backends you might want to look at would be AppRule, which basically splits things into, it's sort of like user and pass, but for machines. You have kind of a not so secret credential, kind of like slightly sensitive, and then an actual secret credential. There's cert, there's user pass, which is just username and password, and then there's straight up tokens, which can be gotten in a bunch of different ways. And the main thing to think about is reboot survivability to make them part of the post-reboot flow. So normally if you're going to reboot a machine in production, you have some mechanism for doing that. Build into your mechanism some way of getting a new Vault token to that machine. For VMs, it's actually pretty similar. It might depend if you have an orchestration system for your VMs, but it's often the same as bare metal, but without a TPM option. But you can usually SSH into a VM. Containers, leverage your orchestrator. If you have Nomad, built-in Vault support, it's pretty nice. And it verifies, when you submit a job as a user, it verifies the user submitting the job, it verifies their level of access against what they are requesting for their application, which is really nice. So it means that a user has to have that level of access in order to give it to an application that they're running. Mesos, there's a third-party thing called Vault Gatekeeper Mesos that a lot of people use pretty happily. Kubernetes, there are some various third-party options. We are working on more. That's all I can say right now, but we're talking with the right people. And Cloud Foundry, there's Vault Service Broker, which is something that we maintain. AWS, right now AWS, if you're running on AWS, is maybe the easiest way to get a token because we have this AWS auth backend that can use either EC2 metadata or IAM. And if you are using EC2 machines, you can do things like match IAM instance profiles. I think you can match like subnet IDs and VPC IDs and all sorts of things to really kind of have granular control over what policies you're giving out. But because it's IAM at this point, you can use EC2, ECS, Lambda users. There's one company that we know of where your first day you get IAM credentials and you're expected to use that for everything else, absolutely everything else that you do. So now that company can say, all right, well, get your Vault token through that. Non-AWS, nothing yet, but we're working with cloud providers. We're in talks with many of them, and they want to support us. We want to support them. For users, LDAP, GitHub, Okta, Radius, these are all things that exist. And we have some things going on in the future, so I can't give any specific dates yet, but things that are actively like in the pipeline, there are PRs or people are working on them that we know of, are OIDC, Ping Identity, GCP, which I think they now want to call Google Cloud, Kubernetes, Azure, or Chef. So some notes that kind of regardless of how you get that token there, for long-running services, often the best thing to do is something called periodic tokens, which every time you refresh that token, you get the same TTL. So if the period is 2 hours, every time you refresh it, doesn't matter how much time there was left, it goes right back up to 2 hours. And the nice thing is you can keep that lifetime low, and you can scope it with your application lifetime. So if your application, like basically if your application runs for 4 hours, it's fine. If your application runs for 40 days, it's also fine, as long as it keeps that refreshed. But when your application goes away, within 2 hours, that token's going to be gone, and all of its leases as well. Full failures. So it's often easier to build in getting a token to a machine as part of like the deployment process than it is as part of a reboot. So sometimes, especially in like container workflows or even VMs, sometimes it's easier to just say, you know what, if something goes wrong and I want to fail, just tear down the machine and have like my orchestrator start a new one. Get a token in that way. And most importantly, talk to us. Me saying that I hate giving talks about secure introduction is not saying I don't like talking to people about it, right? So I'm more than happy to talk to people about your workflow, your needs, et cetera. The mailing list is great. Talk to success engineers about what your set of applications and your infrastructure looks like. We're here to help. It's just one of those things that it's really hard to go and say, here's what you should do, because it's going to depend strongly on so many different factors. Okay, you have a Vault token. Congratulations. So let's talk about some things we can do to it. So going back to this diagram, first up, let's talk about machines and apps. And we want to have a way for them to talk securely between each other. So one way to do that is mutual TLS. Probably not the most fun thing. In fact, certificates, generally when I talk about certificates or when people talk about certificates, this is how they feel about them. They wanted to just throw their computer against the wall. They want to destroy everything in sight. The nice thing is Vault is actually a very flexible certificate authority. It's designed for intranet use, right? It's not designed for the public internet where you have something like Let's Encrypt that does a great job of proving who you are in the public internet. Vault's certificate authority is very specifically designed for your infrastructure, to get your infrastructure talking to each other. It's entirely API driven, so it's very easy to get certs to your host. There's no kind of manual enrollment. If you've ever used, I wonder if I should say this out loud, I'll just say ADCS. For those of you that know what that is, this is much easier. Roles are extremely granular. When I say that, I really mean it. Here are some of the role options. You can constrain on domains, subdomains, globs, wildcards. You can have subject to alternate names, DNS, IP email addresses. You can control key usages. You can control extended key usages. You can use CSR signing, or you can generate keys. They can be ECDSA or RSA. And you can impose static OU and organizational values. And we're always adding more things to this. So this is something that you have a lot of control over, and this is all per role. So at any given time, you can say, I want this set of machines to have this role, which gives them these particular permissions, this set of machines over here to have totally different things. And then you can control, based on the policies on the token, who can get a certificate attesting to what. And from there, you can deploy them and have mutual TLS authentication. So you can use multiple mounts. So you can have your root that has, say, like a 20-year cert, if you want. You can have multiple intermediate mounts, switch back and forth to handle key rolling requirements. Okay, mutual TLS, solved. I'm gonna color that green, gone from red to green, everything's good. Okay, so now we have some databases. We need to talk to those databases. Database connections, things you wish were HTTP 2 but aren't for the most part. They're increasingly getting more HTTP based, but not yet. So we have this database backend that Mitchell talked about where we've consolidated things that existed into one. And for those who don't know, unique credentials are generated per call. So credentials expire, they can be revoked, they can be renewed, and they're plugin based, so you can actually build your own. You can modify ours. You can actually modify ours and then just inject that plugin without like rebuilding Vault. And you can create external plugins. So one of the reasons for this, for those who don't know, is we'd like to, I'll get to this in a minute, but we really want to support Oracle. And there's no Oracle library that's pure Go. And we really like having Vault built statically. It has some really nice features, such as not having to depend on various libcs, which also kind of decreases our security attack surface. So we really like having Vault built statically, but we can't really build in Oracle support without using Cgo, which is like dynamic linking. And so one of the reasons we did this redesign not only was to kind of sync up options and prevent a lot of like copy and pasted code between the various backends that have proliferated over the years, but also so that we can support external plugins that themselves can be dynamically linked, but can be spawned off by Vault and use our Go plugin methodology. So that's a really nice thing, which is we can now support many more databases than we could in the past. Someone who's interested and wants to build something can just build it, use a dynamic library, and we're good to go. And of course, the connection should be secure to mutual TLS, but we just covered that. So we have Cassandra, Mongo, MS SQL, MySQL, MariaDB, Aurora RDS. The plugins actually can have variants, which is kind of nice. That's another reason we wanted to do this. So you can basically have the same underlying plugin code, but which plugin you use basically changes things like the username length that's supported. And Postgres. Expected soon, these are things that we actually have like PRs for that we're working on is Oracle and SAP HANA. We also have RabbitMQ, which isn't listed here just because it's not in the combined database backend yet. All right, connections between machines, apps, and databases, solved. Let's talk about databases themselves. Databases, Dumps happen more often than anyone would like. We've all seen the news. Sometimes those dumps have kind of unimportant information. Sometimes they have very important information. They really wouldn't be that much of a problem if they were actually encrypted, and they're usually not. There are various methods, without going too much in the weeds, there are various methods of encrypting data in databases. There's the built-in methodology. So this is supported by various vendors. It's vendor-specific. It's usually very simple. You don't have to know anything about it as a client. It's often not searchable. It just sort of like takes what you bring in, encrypts it, sends it off. Some have encrypt-only capabilities like Mongo, some don't. But one of the keys is key management encryption methods vary, right? Every database you use, you have to deal with that separately. There are some proxies like CryptDB, which sits in front of MySQL or Postgres. And they're also very simple. You might have to have some code changes for querying. They support some kinds of queries. They can actually do some really cool things with them. Although to support different types of queries, as you say, like, okay, I want to now have this kind of query on a mount, it actually may adapt to like a lower security type of encryption. And they may support derived keys. CryptDB does, which is pretty cool. But there's limited vendor support. So then you have, that's kind of like two classes there. Then you have a third class, which is external. This is what Vault can do for you. So the first part is non-deterministic ciphertext. When you encrypt, the ciphertext is different every time. So there are extra steps in the application to perform encryption because you have to encrypt it yourself and then send it off. It's not searchable. It may support derived keys. So you can have like different keys that are used for every row of your database, let's say. Derived keys, for those who don't know, you provide some context. It takes the original key, applies this context, which is usually not secret, applies a context, generates a new key, and uses that to encrypt. So you can just store the context in a column. In your database, you can have like a different encryption key per row. But the nice thing is there's full DB vendor support. It's opaque data. So any database you can dump in opaque data can store this kind of ciphertext. And then there's deterministic ciphertext. The difference here is that you can search for exact equality. And I'm going to get to that in just a moment. So the suitable mechanisms are dependent on the workload. And Vault supports external encryption, obviously, both deterministically and non-deterministically. But the nice things are that Vault brings to the table is access to encrypt and decrypt are using Vault Auth and Auth and auditing, right? Single unified API. You configure it once, it's going to get audited when someone encrypts something, decrypts something. Batching, so we support batching, so you can encrypt a whole row at one point in time, which is nice. And keys never leave Vault. So you're trusting Vault, and you're trusting Vault's security model and Shamir secret split and all this kind of stuff that you get built in with Vault to handle your keys instead of sending them around or instead of having them in different database services that may or may not store them securely, et cetera. So you're putting that trust in Vault, and you're putting that into a single root of trust. So our deterministic ciphertext encryption, which I'm going to talk about in an example, we call it convergent encryption. It's part of transit. It requires using derived keys, which is providing this context that I talked about. And it's suitable for a wide range of workloads where exact matching is sufficient. So I'm going to look at a hypothetical mortgage application as an example of how you can use this. So taking this view, I've added a Vault logo there, and I've turned the user to an applicant, right? Someone that wants to apply for a mortgage. So step one is they submit their data to an ingress application. By ingress application, I mean they submit it to a service that's taking in their data from the internet, including social security number, which is, for those that don't know, that's like a government ID number in the US. Next step is the ingress application encrypts the fields using the social security number as context. And it stores the result in the database. So one key here is that the ingress application only needs encryption capability, not decryption. So if someone comes on the internet and they own your encryption application, they can't use that to actually decrypt any fields from your database. They don't have permissions. So they can dump the fields of your database, right? They can dump all the ciphertext they want, maybe, if they can query it, but they can't actually decrypt it because Vault doesn't let them. So now let's say a loan officer is now the new user, and they're on an internal network, and they want to find applications. They've gotten the SSN from the user, and they're trying to pull up their application. So they go to a different application here, to an internal app that has encrypt and decrypt permissions. The app encrypts the SSN and gets the deterministic value back and queries the database for fields that are matching. The database is looking for an exact match on that deterministic ciphertext, returns it back. The app decrypts those fields through Vault, returns it to the loan officer. So if exact matching is sufficient, Vault provides searchable ciphertext. It's completely database agnostic. And the nice thing is you can migrate data between databases without ever decrypting. So if you have like built-in support, let's say in Mongo or something, you want to pull out of Mongo, you decide you want to switch to Postgres. When you do that, chances are you're going to have something that is decrypting all data from there and piping it in somewhere else using maybe the same key, maybe not. It might depend on how it was encrypted. It might depend on the capabilities. But in many cases, you're going to have to do that. And so that's something you don't have to deal with when you're doing external encryption. As long as that service is around, then you're fine. And there is a way in transit you can mark a key as exportable. You can only do that when you're actually creating the key, but if you're worried about somehow the key getting lost, you can mark that as exportable, and then you can export that key if you have the permissions to do so. Once a key is marked as exportable, it can't be changed, but it's read as part of the key properties, so at any given time, you can know that that is a key that may exist outside of Vault. All right, databases. Solved. Let's talk about the user and browser. And by the way, it's a relatively simplistic example. There are lots more things that Vault can do, and there are lots of things within such an example that you can be like, all right, you're not touching on that. I realize that, but I only have 12 more minutes, so got to stop somewhere. Second factor authentication. Why you need it? Because people's phones are worth more to them than your security. TOTP, those QR codes that always scan blurrily before they're magically accepted. Mitchell talked a lot about the TOTP backend, and so some of this will be familiar because he just talked about it, but I'm going to go through it in a little bit more detail. So it's a time-based derivation of an access code from a given key. And so Vault does two things in this arena. There's actually kind of two functionalities baked into the same TOTP backend. One is you can give it a key that was generated externally, say AWS, and you can control access to those codes from Vault. So a nice thing is you can say like, all right, you already have a Vault token, we'll just pop this in there, and if you want to do something in AWS, while you have a Vault token that gives you permissions to do so, you can pull access codes out whenever you need, and it's audited. The other thing is it can generate and store keys and then allow validation of submitted codes. So I'm going to show what that looks like. This is using the CLI. For those who don't know, the CLI is just an API client, right? There's nothing magic that the CLI does. Anything that you can do in the Vault CLI, you can do over the HTTP API. That's a really important point that a lot of people don't realize when they're starting out, is that this is just something that we try to help like make it easy to just like write some stuff in, but it's very flexible. So enroll a user. So there I'm just doing, I'm doing a write. I don't know if you can see it easily, but I'm writing to a key. I'm saying, please generate a new key. I put in an issuer. I give it an account name, and I get two keys out. One is the barcode, and the other is the URL. And the URL can be given to a user. The barcode is just taking that URL and it's encoding it into a PNG QR code. So just as an example, I'm taking that exact value, I'm dbase64ing it, piping it to display, and you see you get a QR code. I did actually, for the next example, I did actually scan that with my phone. I can't prove that to you right now, I don't have my phone on me, but I did actually scan that with my phone for this example, which is showing, so the first code up front is valid, and then I change one digit below, and you see that it's not valid. So the nice thing is, you basically, in your application, you can say, please enroll this user, here's their user ID, please enroll them, and then you can take this value that comes back, show them a QR code, or give them the URL that they can like copy and paste, right? And then from there, any application that you have, you can just make a very simple call. This user says, I'm this user, here's my code. You just go and say, is this valid or not? Two-factor authentication everywhere. And other tools that provide TOTP are very easy. There are node modules out there, let's say, that provide TOTP. It's really easy, but key management is up to you. So again, Vault's giving you this unified auth-in/auth-z model, unified auditing. You can control what the security over that connection looks like. It's a very flexible system for security where you have a single central point that you can make sure that everybody, when talking to sensitive information, is on the same page. So having that key management for you is really, really nice. You don't have to worry that it's being like left out in the open somewhere. Okay, so 2FA for users and browsers. Quick bonus round. Taking this, what if it was user and application instead of user and browser? So let's say that you are a small startup becoming a bigger startup, and you are selling enterprise versions of your software, and you want to make sure that people are doing the right thing. You don't want to be too onerous, but you want to make sure that they're doing the right thing because it's kind of part of what you got to do. I don't know any companies that might be like this, but maybe you can think of some. Licensing, because native apps still exist. Vault does encryption as a service. It also does signing as a service. It's one of the things that it does in transit. I mentioned before that some of the things that can be very overwhelming is that you have tools, which are backends, then you have tools in tools. So off the top of my head, the transit backend does encryption as a service. It does this convergent encryption. It does encryption with key derivation. It supports asymmetric keys with ECDSA, with the P256 curve. It supports ED25519 as the latest release for asymmetric signing. It does hashes. You can hash like SHA-SUMs. You can do HMACs. You can get random bytes. It does a whole lot of stuff. Vault can actually act as a license management helper using asymmetric public-private crypto. It's a pretty easy workflow. Here's what it looks like. You can encode allowed features and validity start end periods into a structured format like JSON, serialize it. Have Vault sign the serialized bytes with a private key that's never exported. The serialized bytes and signature are provided as a license string. Public key is baked into your binary, and the binary checks on startup whether the signed data that's submitted by the user is valid and configures features and expiration. Pretty simple, pretty easy, not very onerous, but it makes it easy to kind of do the right thing. You can do this on the command line with your own key management, but why? Why are you going to do your own key management? Leading to Vault, because why not? New slogan for us. And you can do some like advanced concepts if you wanted to. So for instance, you could use the ED25519 key system that we baked in. It supports key derivation. So you can say, all right, let's use some kind of customer information as context. And so we can have a single key within transit, but every customer is actually using a different key. And then create a unique binary. So a user says, I want to download a binary. And you just pop that public key in the binary source code, build it, they download it, and you have a binary with a public key specifically for them. Now, a mismatch of license and binary won't be valid if people are really trying to do the wrong thing and they are sharing both license and binary data to each other, then it's not going to stop them. But you kind of go on the assumption that people are going to do the right thing, right? And incorporate installation data into signed license information, right? So you can say, here's some local installation specific information. Take this local information, put it into the license, and then build the license and sign it, and it's specific to that installation. So you can say, all right, you can't just copy this license around to each installation. All right, so in conclusion, we think of Vault as a security Swiss Army knife, and hopefully you're seeing like what we mean when we say that. There's a large number of organizational security needs that we can address with it. It has this unified access model, auth-in, auth-z, audit. It can solve functionality requirements at every level of infrastructure and application, and its collection of tools is fairly large already. It's going to continue to grow. And tools alone cannot meet enterprise organizational governance needs, which is why we have existing enterprise functionality, such as the scaling mode of replication, and scaling new ones quickly. So things that we have planned in the near term include disaster recovery mode for replication. So for each cluster, you'll be able to say tokens and leases. We want to also have this set to a DR secondary, and a given vault can actually be both a replication secondary and a DR primary. So the nice thing is you can say, okay, we have leases and tokens. We actually want those to be like backed up in a DR scenario. And so you can have a DR secondary that has everything local that local cluster has. And then that DR secondary, it doesn't handle requests, but it's there ready to fail over to if you need. And the reason it doesn't handle requests is for the same reason that was talked about before, which is if you want to build something performant, if every single call that you make has to like reach all the way back to the primary in order to properly check tokens, then you're not going to get any performance benefits out of it. And you really have to do that because if you don't, then you have a really easy scenario for someone to send calls to multiple vaults at once and attempt to kind of exploit a race condition between when tokens are updated. So everything that we build in, we try to be very, very secure and really think through all the ramifications of these things. Per mount replication is also in the near-term roadmap. So you'll be able to say, for a given secondary, I actually only want these mounts to go over there. So imagine that you have data centers in different countries. You have country-specific information. You see no reason to have that information outside of headquarters, like sent to all the different other countries. You can say, okay, for this country, I want these 3 mounts, and for that country, I want those 3 mounts. Other things, I'm not sure if this will appear in the next release, but it's on the near-term roadmap, is MFA everywhere. So you're going to have the ability to use Duo or TOTP throughout all of Vault's API. We have a couple authentication backends right now that can use Duo in a very limited fashion for logins. I'm talking everywhere in the API. Like any call, you can say, if this, this access policy requires it, then you must always provide some kind of second factor authentication. So we're really looking at a lot of these enterprise needs for organizational and governance, and we're putting a lot of good stuff into Vault. So thank you very much.